Last part, part C of the AP0506 practice problem. So two Lewis structures can be drawn for OPF3. You see them there, structure 1, structure 2, molecules shown below. How many sigma bonds and how many pi bonds are in structure 1? This couldn't be easier, okay? Here's what a sigma bond is. Anything that is a single, there we go, anything that's a single bond like this, that's a sigma bond, okay? That's what sigma looks like, that symbol. If I have a double bond like that, then one is sigma and one is pi. So in a double bond, I have one sigma and one pi. In a triple bond, where I have a triple bond like this, I have one sigma and two pi. So I have one sigma here, like that, and two are pi. So in this case here, I have 1, 2, 3, 4 sigma bonds and one pi bond. Okay, so it says, what do I have? I have 4 sigma and 1 pi. That's the answer to that one. Super quick, super easy. So everything that's a single bond is a sigma. One of the bonds for a double and one of the bonds for a triple is sigma. The rest are pi bonds. Which one of the two structures best represents the molecule? OPF3, justify your answer in terms of formal charge. What is formal charge? Well, here, in case you're not sure, formal charge is a way to check to see which between two structures is the preferred structure by looking at the number of valence electrons versus the number of electrons assigned. Okay, so let's take a look at structure number 1 first. So for structure number 1, I'm going to erase some stuff here so that we can continue on there. So I got my P, I got my O, and then I got 1, 2, 3 F's. I have to show which ones they are. I have my P, I have my O, I have F1, F2, and F3. I'm going to take my valence electrons. Now that doesn't matter like what structure it is, it doesn't matter what the elements are bonded to. Valence electrons are these things that we see going back to here. So it's P, O, F3. So P is 5. I got 5 valence electrons there. Oxygen is 6, and each of the F's is 7. That's where I'm getting these numbers from for valence electrons, right on the periodic table. So when I go back here, I have 5 valence electrons, 6, I got 7, 7, and 7. Then what I do is I go back up to the structure and I start to assign electrons to these elements. So for P, let me get rid of this here. So for P, this is the second F there. So for P, I have 5 electrons. If I break each single bond and each double bond, and then I have 1, 2, 3, 4, 5 electrons. So I break the bonds, and which like the 2 electrons for a double bond go to the P, and 2 electrons for the double bond go to the O. So 1 sigma, yeah, there. So if I go back through now, and I show you that for, I probably shouldn't, I'll have to write that one out and then move it to the side. Okay, yeah, that's working, great. So I have 5 assigned electrons for the P. Then I have how many for oxygen? Well, I made a dot on there, and I got to get rid of that dot there. So then I count the number of electrons I have. I have 1, 2, 3, 4, 5, 6. So I got 6 assigned to oxygen. Let's take a look. For all of the F's all work the same way, so we're actually kind of lucky in this case. Sometimes it doesn't work out that way. But I got 1, 2, 3, 4, 5, 6, 7, And since they all look alike, I got 7, 7, 7. And you go, of course you're thinking to yourself, why the hell am I doing this? It doesn't seem like it's doing anything. I'm getting zeros for subtracting all of these. The number of valence electrons minus the assigned electrons. You're like, I'm sure you're thinking, like, am I even doing this correctly? Well, you are doing it correctly. And the reason why you're doing it correctly is take a look what happens if I do the other one, the other structure. Now I think even with this one, it's the oxygen that changes. It is the oxygen that changes. So I'm going to just write down the F, F, and F. There, F, F, and F like this. Valence electrons are exactly the same as it would be if I could write the right number down, the correct number down. So it's 5, 6, 7, 7, and 7. The assigned electrons is different now. It is, it's different. If you check it out, you'll notice that for the assigned electrons here, when I go back up to the structure, what did I do here? For a single bond, I cut it in half. One electron goes to the phosphorus, one goes to fluorine. Cut it in half, one goes to phosphorus, one goes to fluorine. Cut it in half, one goes to phosphorus, one goes to oxygen. Cut it in half, one to fluorine, one to phosphorus. So that means if you look, and I'm going to keep it close here so you can see what's going on. If I count the number of assigned electrons to phosphorus now, since I split up 4 single bonds, I only get 4 electrons, which means what I have here then is a +1. Take a look what happens to the oxygen. I need to go back up just a little bit for this. Now I have 1, 2, 3, 4, 5, 6, plus 7. Now I have 7 assigned electrons, which means now I'm at a -1. Okay, what about the other fluorines? I got 1, 2, 3, 4, 5, 6, 7. Okay, so these fluorines don't change at all like this. We got 0, 0, and 0 for that. So now come down here and take a look. I got 0, 0, and 0. So the fluorine, they don't change the structure at all, but the P and the O, I got a +1 and a -1. So which one of these is better? Clearly, the one where the number of valence electrons and the assigned electrons are the same is the better structure, because that is the natural, state of that element. To have, like, if I assign electrons and it's the same number as the valence electrons, that's a stable situation. So here I have 0 and 0 for oxygen and phosphorus, which makes this structure number 1 the better choice. So the better choice is structure number 1, because the formal charge, which is valence electron minus assigned electron, means that this one here holds like a more stable structure, because of the way we have a single, and the double then between the oxygen and the phosphorus allows phosphorus to have 5 valence electrons and 5 assigned electrons, and oxygen to have 6 valence electrons and 6 assigned electrons. That's the difference there. That's page, by the way, that's page 320 for formal charge. If you're completely lost, I would recommend, I would recommend you checking out page 320 in the book on formal charge. That is chapter 8. Okay.